Good morning, Tubes. Materials evaluation. One of the places I used to visit were materials evaluation labs. These were destructive and non-destructive testing labs that would take failed materials and analyze them for the reason for failure. One of the labs I went into, a small private lab, maybe only, and this was a small private lab in Louisiana down a muddy back road, had, I'm going to put it at about $2 million worth of equipment inside this lab. It was an interesting place. What did this place do? You fly in, you rent a car, you get to where you're going. He tested stress failure from drilling and nautical ship work, drill rigs. When a piece of material fails, it would be sliced and a sample sent to him to analyze. He would analyze at the atomic level, the elemental level, the isotope level, the stress fracture, and state clearly why it happened. Fatigue, bad metal. One of the keys in industrial, especially military airframes, is damage from materials in the air itself that will destroy metals. Things like, if I can remember them, cadmium, selenium. Some of these elements, if an aircraft flies through a crowd of it, will actually destroy the airframe. This is the level of details that these people in materials evaluation labs are doing. Where were these labs? Who did this types of testing? I worked professionally in the oil field doing destructive and non-destructive testing for oil field tubular goods, meaning any kind of pipe you can think of, and a lot of services around that. So that was mostly non-destructive testing services for metal goods. It included nuclear type of testing called through-wall gamma detection that relies on interferometry of gamma rays through metal to deflect a signal so a detector can see the thickness of a tube. That's how hard and simple this is. So non-destructive testing and destructive testing, two kind of discrete fields out there. Non-destructive you would use before something fails. You go and look for the cracks with electronics that can't be seen with the eye. They use a type of radar to look inside the metal and see the stress and the structure of the metal. It's a very defined, very cool business. That's a materials evaluation lab. There's many fields. There's airframe, aircraft. There's metal specialties like aluminum failures versus steel and structural failures. So these are the labs that exist out there in the countryside. They're private labs. They're professional labs. They're university related. They are federally related, funded mostly by projects from Department of Defense activities, because somehow defense, we're scared. So that's materials evaluation from 25,000 feet aircraft flying in to service something, knowing that that aircraft has risks associated with it, and you're going to labs that do these. The Air Force lab specifically was looking at jet engine turbine parts. A lot of other parts as well, but that was kind of their focus, is those little ceramic or titanium, whatever they are, blades on the end of a fan, staring at them for a living and a paycheck and a career. This is the sciences out here among us.